Okay, so to start the basic differentiation rules, we need to establish some things. For example, binomial expansion is one of them. When you raise something to the first power, it is just going to be x plus delta x here. If you square it, you can just use any binomial squared, x squared plus 2x delta x plus delta x squared. And then to find out x plus delta x cubed, you take the answer you got, number 2, and just multiply by, so here these all have equal signs, by the way, x plus delta x times x squared plus 2x delta x plus delta x squared. And then I'm going to multiply those out. There's a couple ways you could do that. One quick way is it's almost like an expanded foiling. I know that the inner and outer set, here is an inner set and an outer set, are going to be like terms, like that. So you start with the first 2 terms being multiplied, which is x cubed, and then where you see the highlighted in pink and then highlighted in yellow, if I multiply those two together, those 2 sets together, they will be like terms. It'll be x squared delta x, and the other one would be 2x squared delta x. So in other words, I just have to add, there are 2 of like terms, so I have to add those 2 together. I get 3x squared delta x. That's one set. Now I can go in and erase that here and then find another set. So I do, it's sort of like an expanded FOIL again. This is now an outer set, so I'm doing 2 at a time. And then maybe I'll do blue for this one, and an inner set there. If I multiplied the outer and the inner, it's going to be x delta x squared, both of them. So one is going to be 1x delta x squared, and the other set in blue is going to be 2x delta x squared. So when I add those together, I get plus 3x delta x squared, and then the last is delta x cubed. Now, if you remember from binomial expansion, that's another way you could look at it, is using Pascal's triangle. So I know what the coefficients are going to be based on Pascal's triangle. I know that the first variable in the binomial has to descend, so it's going x cubed, x to the second, in degree, by the way, x cubed, x to the second, x to the first, and then the last term has x to the 0. That's why there's no x there. And then the delta x is ascending, so it's x, delta x to the 0 you don't write because it's just 1. And then delta x to the first in the second term here, delta x to the second, and then delta x to the third in the last term. And if you remember from Pascal's triangle, it tells us what the coefficients are going to be. And the way to calculate the coefficients is you start with a triangle, and to get a new row, you take the row above it and add the 2 coefficients to get the piece in the middle. So here, if I had, for example, a plus b to the 7th, I would start with a 1, add 1 and 6 gives me 7, add 6 and 15 gives me 21, and then we get 35 for this row, 35, 21, 7, and 1. Some things I want you to notice. First of all, the first and the last are all 1s. These are all 1s here. Now for the next level, the next piece inside, these all match their particular power. So the coefficient matches the power that you would have had. So for example, a plus b to the 7th, the second coefficient and the second to last coefficient both will be 7. The same for a plus b to the 6th, the second coefficient and the second to last coefficient each will be 6. So if I had a plus b to the 20th, I know that the first coefficient will be 1 and the second coefficient will be 20. And the same on the other end, the second to last will be 20 and the last coefficient will be 1. So armed with that information, I have this one, the next one here. If I expand, I can look at my Pascal's triangle. I know the coefficients are going to be 1. It's going to be 4. It's going to be, oh, I have to look over here, 6, 4 and 1. And it's going to be x to the 4th, x to the 2nd. No, not to the 2nd, to the 3rd. I'm going down by 1. Hello? X to the 3rd, x to the 2nd, x, and then x to the 0 power we don't write. And then delta x to the 0 power for the first term we don't write, but then we have delta x to the 1st, delta x to the 2nd, delta x to the 3rd, and then delta x to the 4th. And then it's going to be a plus in between all of those. Obviously, you don't need to put the ones, but that's how to quickly expand. So now I want you to try number 5. Hopefully, you'll get the same as I do. Like that. Now for number 6, we're going to do a similar thing, but now it's to the nth power. So instead, I'm just going to predict, and then I'm going to use some variable to indicate some of the coefficients in the middle terms, because I don't know how many terms are going to be. But some things that I definitely know. I know the leading coefficient is going to be 1, so it's going to be x to the n is going to be the first term. I don't need to write the 1. I know that the second term is going to be, the coefficient is going to be the power, which is n, and then it's going to be x to the n minus 1, and we're going to have 1 delta x on that. And then we're going to end up with a bunch of middle terms. And I know something similar happens at the end. It's the second to last term. The coefficient will be n as well. We're going to have x, but now it's going to be the delta x that's going to be to the n minus 1. And then the last term is going to be 1, and then delta x to the nth power. And then all of those terms in between, it's going to, for example, the next term could be some constant, whatever that is. Okay, there is a way to find it using combinatorics, but that's not what's important here. The key is you know that you're going to go down, the x powers are going to go down by another one, so that's going to be n to x to the n minus 2, and then delta x squared, like that, and then so forth. But again, the middle terms aren't as important as the end, or the front and the end. You know what's going on there.